I'm going to go ahead and do the review. I'm going to first talk about dilation. We do have a dilation here, and here is the center. Here is the pre-image, and then here is the image. And in this example, we know that the pre-image is enlarged by some type of scale factor, and we call that n. So what I'm going to go over is briefly explain what a dilation is. It can either be an enlargement or it can be a reduction. In this case, it says here that we have A, B, C, D. That's the pre-image. And here is the new image or the image. So for us to find the scale factor, we need to know the measurement of the image, which is 4, and then compare it to the measurement of the pre-image, which is 2. So what is the scale factor? 2. So that tells us that is an enlargement of 2. In contrast, we have this image FGH, EFGH. It starts off with 8 and it ends up with 2. So we want to start off with what was our image amount. In this case, the image measurement is 2, and our pre-image was 8. So that's going to be 1/4. That's going to be our scale factor. The blue image is a dilation image of the black figure. So in other words, the black figure is the pre-image and the blue is the image. The center here is A. Tell whether dilation is enlargement or reduction. So in this case, the final image is the larger triangle, so that will be an enlargement. And remember, we want to start off with what was our image amount. In this case, it's 6. And our pre-image is 4. And we know that we can simplify this by a factor of 2, so it's going to be 3/2. So this was an enlargement. In contrast, our pre-image here is, well, for example, number 4, our pre-image here is this larger square, and our image is the smaller square. We notice that we ended up with 2. So it's going to be the ratio of 2 to 1, 2, 3, 4, 5, 6, 2 to 6. So in this case, it's a reduction. So this one's an enlargement, and this one is a reduction. Number 10, the blue figure is a dilation image of the black figure. So this is our image, and the black triangle is the pre-image. And we notice that this will be an enlargement. Now we need to figure out the scale factor. So I'm going to count the base of the blue triangle. 1, 2, 3, 4, 5, 6. So that was our final image measurement for the base. And then the pre-image was 3. So the scale factor was 2. It says graph the polygon with the given vertices. We're not going to do that, but I'm going to show you how to find the image, and here's the pre-image, MATH, a scale factor of 5. So what we have to do to each of the coordinates, we have to multiply by 5. So we want to find M prime. It's going to be 5 times -3, which is -15. And then 5 times 4 is 20. A prime will be 5 times -6, which is -30, comma. 5 times -1 is -5. T prime is 0, 0. H prime will be 15, 10. So that's how we figure out the coordinates for the new image, is we multiply the x and the y by the scale factor. Point A is 3, 2 is reflected across the y-axis, and then rotate it 90 degrees clockwise about the origin to point A prime. So here's A, and here's the reflection. It's 3, negative 2. 3, negative 2, that's a reflection. And then for us to do the rotation of 90 degrees, we have to change the variables x and y, and then we make the x, we go ahead and make the y value opposite in value. So it starts with negative 2, and then we have 3, and then it's going to be negative 3. So it ends up negative 2, negative 3 ends up right here. That's going to be A double prime. I use prime here because that was the first one. That was the first transformation. That was a reflection. And then we went ahead and rotated that. In the coordinate plane, which transformation does the following? What I did is I selected B because y equals negative x is this line. We're going to reflect 1, 1. That's just an example I made up. It's going to be negative 1, negative 1, and you notice that the x, y become negative y, negative x. So your answer is B. It's matching this rule. Triangle JKL is translated 3 units left, 2 units down, and then reflected over the x-axis. What will be the coordinates of point K? So I'm just looking at K. I have to go to the left, 1, 2, 3, go down 2 units, and then remember that the line of reflection is the x-axis, so it's going to reflect here, so it's going to be K prime right here, which the location is 3, negative 1. Now I didn't do that for the rest of the points, I was just worried about K, so it's going to be D. In the grid below, triangle ABC will be rotated 90 degrees counterclockwise. So I have x, y, negative y, x. So all these x values, these y values will become negative. So I did that rotation. Then it's reflected over the y-axis. So we have A that is reflected over the y. So the location will be 4, negative 9. So the answer is B. So we're talking about trigonometry, and remember I told you to remember the mnemonic statement. So, ka, toa. Sine is opposite of hypotenuse, tangent is opposite over adjacent, cosine is adjacent over hypotenuse. And if we're looking for A, sine of A, it's going to be opposite over hypotenuse, which is 16 over 20. Tangent of A is going to be opposite over adjacent, which is 16 over 12. And then cosine is adjacent over hypotenuse. Each of these can be simplified by a factor of 4. So that's why we got 4/5, 4/3, and 3/5. Find the value of x to the nearest tenth. So we're trying to find the angle. Now, what do we know? It's a right triangle. We know there's the opposite side, there's a hypotenuse. So we're going to use sine is opposite of our hypotenuse, which is 12 over 22. And then we're going to use inverse sine. You go to trig, inverse sine, trig, inverse sine, and then you're going to type in 13. Take that back. 12 divided by 22. And so it's going to be 33 degrees. Number 6, a roofer leans a 20-foot ladder against a house. The base of the ladder is 7 feet away from the house. In this case, you just have to use a Pythagorean theorem. So you have 20 squared equals 7 squared plus x squared. To find x, you got to subtract these two and then get the square root, so it's 18.7. Which ratio is used for tangent? Remember, tangent is TOA, opposite over adjacent. Which ratio is used for cosine? Remember, cosine is adjacent over hypotenuse, so your answer is A. Josh tied a helium balloon to a stake. The wind blew it so that the 10-foot string attached to the balloon made an angle of 45. So that's angle of elevation. So we know that we're going to have the opposite and the hypotenuse. So sine of 45 is equal to the h, which is the height, over 10. You cross multiply, so your answer is 7.1 feet. Sid drove home from the museum. He drove 2 miles due south, 3 miles due west. We have opposite and adjacent, so it's going to be the tangent of x equals 2/3, and we're trying to find the angle, so we're going to use the inverse tangent. So your answer will be 34 degrees.